This conference will now be recorded.
Very good morning, students. Today onwards, we'll be discussing and solving numerical problems from the JEE Mains papers 2024. So I have got today some questions from the paper 4th April. 4th April, shift 1. So we'll try to understand the questions and solve them accordingly. So let us start our discussions for today. So the first question, you see, this is from ray optics part, and it says 5 identical convex lenses are placed one after another in close contact. That means it is talking about combination of lenses, and by default we will take these lenses to be thin lenses. The power of this arrangement is given, that is 25 diopter. Then power of one such lens is 10 diopter, 5 diopter, 125 diopter, or 20 diopter. You have to find out the correct option out of this four. Okay. So look, when there is a combination of lenses, then actually power of the combination will be the sum of the power of individual lenses, like this. If I have 5 lenses here, then I can write P is equal to P1 plus P2, sorry, P3 plus P4 plus P5. Okay, so power of each lenses, see, these are actually identical convex lenses. So if I take the power of each of them is P, then I get 5P, and here it is given this is equal to 25 diopter. Okay, so what will be the power of individual lenses? That will be 5 diopter. Okay, so option B will be the correct answer for this question. So this was so simple question. Let us go to this question. This is also a really nice question, and it is from the electricity part. Circuit analysis we have to do here. A cubical arrangement of 12 resistors, each having resistance R, is shown. Find I. You have to find out the current. Okay, so here it was I is entering into the combination of this cubical shape arrangement of resistances. So there are 12 identical resistances, as you see here. You have to find out the current I. What is the magnitude of the current I? Okay, so I see here there was a battery of V0 volt connected across A and B. Okay, this is the complete figure. Okay, I'm sorry for that. Okay, so this is the complete figure. So you have to find out what is the value of this current. So to get the current, what I need V0 by R equivalent, isn't it? So this will be the current. So how do I find out equivalent resistance between this A and B terminals? Okay, we have to find out equivalent resistance in between these 2 points. Okay, see how do I get here? See, I have this resistances, these 4 resistances, okay, and all these 4 on the upper surface, lower surface, etc. So how to solve this problem? How to find out equivalent resistance for this? So there may be many ways to do that, but the simplest way to use the symmetry considerations of the circuit. Look, there is a mirror symmetry over here. You can see that. So, mirror symmetry is always taken perpendicular to the point between which you have to find out the equivalent resistance. So I can actually see, I can show you here that there is a plane. If you think this plane TNMST, so this plane is actually perpendicular to the line joining AB. I hope you understand this. And through this perpendicular line or plane, whatever you say, the resistances will not have any effect. That means what? That means, if I just show you a simple circuit over here. Look, suppose I have resistor like this, then one resistor in between, then another resistor like this. Okay, suppose, okay, so this should be like this. Okay, so I have R, all resistances are identical, R, and this is also R. So what is the equivalent resistance between these 2 points? How to find out? So since these are all identical, I can actually pass a perpendicular mirror, mirror perpendicular to the line joining between this A and B. Okay. All right. So in this case, you look what happens according to the symmetry analysis or symmetry. The current, see, if I say this is current I, and it is actually divided into 2 parts, I1 and I2. See, this I2 will go all the way. See this, see after this mirror symmetry, see this R and this R will have the same current I2, and this resistor and this resistor will have the same current I1. So here you have to think in terms of current. So since this current is same, that means there is no uh, like branching of current or division of current. The whole current I1 is passing all the way up to this one B point. Okay, that means this, we can neglect the presence of resistor, this middle one, which is actually on the mirror plane. So here I have mirror, see, 2 resistors on the mirror plane. See, this is one. Okay, I can just use red ink maybe. See, this resistor and this resistor, these are actually on the perpendicular, sorry, mirror plane. So these resistors will not be affecting, right? If these are not affecting, then what will happen? Look, this particular plane, if you see, so this is the perpendicular axis here. Okay, so perpendicular one. So you have the current I1 passing, like if I say this is I1, this is going to be I1. If I say this is I2, this is also going to be I2. In that way, actually these two will be in series. So these two guys will be in series. Okay, and these two also will be in series, but these two will be, see, this, since they are connected like between the same ends, then I can say this this branch and this branch, they will be in parallel connection. Okay, so what I get then, I get kind of this. You look, these are 2R. I have got 2R like this, and another 2R here, and these are actually in parallel combination. So this, the whole plane, whole surface will have equivalent resistance. See, 4R, 4R by 4R, right? So it will be, sorry, 4R square by 4R. That means R. So the whole, this one I'll get R resistance. Then you have this two again. See, I have only one here which have resistance R. And now I have this R, this particular R, and this R I will have. There, those two will be in effect, and then I have this uh, this lower plane again. Again, I have similar mirror symmetry between these two. Right here, you can see that. So between mirror, so in the mirror symmetry here. So what I'll do, I'll just see this will be in series. This will be in series. They are in parallel combination. Okay. So I have, see there, this is here R, and I have here again R. Okay, so I have to actually calculate the potential difference across this A. Suppose this is A, this is B. Okay, so I have to find out, sorry, equivalent resistance between this A and B. So look, this, these three are actually in series, and this is R. This is series, that means 3R, and this is 4. This will be in parallel. Okay, so I have got 3R into R divided by 4R. So 1R cancels out. So I get equivalent resistance 3R, 3 by 4R, or 3R by 4. So once I get the equivalent resistances, so then what else I have to do? Nothing else, right? Now I have to find out the current I. I is V0 by V0 by 3R. V0 by, okay, 3R by 4. This one. Just let me check this. I think I am just doing some mistake in the figure, whether it is V0 or V0 by 2. I don't. Okay, so I hope this is V0 by 2. Okay, this will be somehow. So anyway, this is the way to do. This is actually, the answer will be V0 by 6R. I think this is 12 V0 or something. Okay, let me just check once the question, whether I have done some. A cubic alignment of 12 resistors, each having resistance R, is shown. Find I. Excuse me. I have to just see this voltage. So what was this? Yeah, this is actually V0. Okay, so anyway, I have got what? I have got the equivalent resistance. Okay, let me just try to find out the current now. Okay, so what is the current? See here, actually, if we see here, this is I have got this battery V0. Okay, so here actually we have to find out current. Okay, current across I see. This is actually find I. Anyway, so let us find out. Look here, I had got actually the equivalent resistance. Like, see, you had uh, okay. So after getting this equivalent resistance, see, I have got one in the upper part. What I have got? See, this lower part I have got. See, this is A and B. Lower part I have got R. Okay, and I have got here 3R. This is parallel circuit. Okay, so now this is V0. So what will be the current through this 3R? Okay, I 3R is equal to V0 by Okay, so let us proceed further. Actually, the answer will be this one. I'll just clarify this once again at the last. Okay, so let me just continue with the second one, like the last, the next question. Okay, on a given rough inclined plane, a solid sphere and hollow cylinder having same radius are rolled one by one. Okay, with same speed. Ratio of heights attained by solid sphere and hollow cylinder. Okay, so we have hollow cylinder, and solid sphere. So these two are actually rolled one by one with the same speed. Speeds are same v. Ratio of heights attained by the solid sphere to the hollow cylinder. So in this case, you have to think that this is an inclined plane. Okay, so you have a sphere, it is rolled. Okay, it is rolled up. Okay, so you have to find out the height attained. If you give certain speed v, then how much height it will attain. So this is the scenario. So in this case, if it is the translational motion, what you would have done, the total kinetic energy. This is energy conservation. From energy conservation, we can actually solve this problem. Energy conservation. So energy conservation, according to energy conservation, we have to see the kinetic energy, total kinetic energy will be exactly equal to the mgh, the potential energy. Okay, so this is the highest height or the maximum height one object can attain. Okay, so now here, what is the total kinetic energy? What is the total kinetic energy here? For rolling body, rolling with, see here, it is actually rough surface. Okay, so there will be no slipping, rough inclined plane, so there will be frictional force. So this motion is actually rolling without slipping. Okay, rolling means translation plus rotation. So what is the total kinetic energy? There is a half. If I say each of them has the same mass, if I say, okay, then you know what we have. For a particular object, I can write half m v square, that is the translational kinetic energy plus rotational kinetic energy, half I omega square, and that will be is equal to mgh. And let us say this is for sphere. Okay, let us say this is mgh1. Now we know the speed given are same, and also we know for a rotation, like rolling motion without slipping, we know v is equal to r omega. Okay, v is equal to r omega, so omega is equal to v by r. So then I can simplify a little bit, half mv square plus half I v square by r square is equal to mg h1. Now this I is actually moment of inertia, as you know. For a solid sphere, it is actually 2 by 5 m r square, and for hollow cylinder, This is hollow cylinder HC. For hollow cylinder it is mr square. Okay, now things will be easy. Look what I have got. I'll just clean this portion. I have got now, see, mgh1 is equal to half m v square. Let us take that common. See this, so for solid sphere it will be 1 plus, only I will be there. Okay, so I is actually I by r square. I by r square means, so this is 2 by 5 m. I have taken common, r square will cancel out and you will get this. So m, let us cancel from both sides. So what I have got here, you look, this is 7 by 5 and this half, so you'll get v square 7 by 10 v square. Okay, from here, okay, similarly using this formula I can use for cylinder. This is half m v square, here 1 plus I, 1 plus mr square, rr will cancel out, so this will be 1 only. So this will give you actually m, sorry, m will cancel. Let us cancel m from both sides. This m, this m. So this will be actually v square, only v square. Now take common, sorry, take the ratio both side. If you take the ratio will be h1 by h2 is equal to 7 by 10. Okay, C, option C will be the correct answer for this question. Okay, so this is actually in the case of rolling up, you can say, along the inclined plane. Okay, along the inclined plane it is rolling up. All right, so we'll go to the next problem further. So next problem. This problem is very simple. Let us try to understand the question. The question says, a wooden block is initially at rest on a smooth surface. That means frictionless surface. Now a horizontal force is applied on the block, which increases linearly. That means the force itself is increasing linearly. Suppose this is a horizontal plane. Okay, so there is a wooden block like this, and this is actually smooth surface. Initially it was at rest, so there was no motion. Now if you apply a force which is actually increasing linearly, that means, you know, your force has, see, with time it is increasing like this, your force. And force, we know, m is equal to, force F is equal to m into a. That means F and a will have the same kind of variation, okay. So here the acceleration at curve, here actually this is acceleration, not p. These are actually accelerations. So acceleration versus time graph for the block, what will be that? Okay, which one is correct here? So option B will be actually, sorry, option 2 will be correct answer for this question. Why this is correct? Because force is having this linear variation, and force and acceleration, they are having the same kind of variation. That is the reason. Okay, now we'll see further a next problem. So what is this problem saying? This problem is saying an electron is projected along the axis of the solenoid. Suppose here the axis of the solenoid is this one, x-axis, say, which carries a constant current. This is carrying a constant current I. The trajectory of electron shall be. See, an electron is projected along the axis. So projected along the axis. That means, you know, the electron will have its velocity along the direction of the magnetic field itself. Okay, as you see the magnetic field directions along the axis means its direction is same. And we know magnetic force. See, the trajectory or path depends on the force acting on that. Okay, here there is no electric field at all. You have only magnetic field while passing through the axis, like through the or along the passing along the axis of the solenoid. See, since these two are parallel to each other, so there will be no magnetic force, because I know magnetic force has got expression for some charged particle having charge E is equal to V, sorry, that F is equal to E into V cross B. Since these two are parallel, so the angle between them will be 0, so this force will be 0. Since there is no magnetic force on the charged particle, it will actually, or the electron, it will move. See, circular motion will not be there, parabolic motion will not be there. Okay, so uniform accelerated motion will not be there, since there is no force acting on it. So uniform motion along x-axis. Okay, so all right. Now this question is also very interesting question. Which graph correctly represents the photocurrent versus stopping potential for the same frequency but different intensity? So we have to understand to answer this question. So here you look, this is actually current, photocurrent, and this is the stopping potential. Okay, so how current actually varies with stopping potential, or what is the relation between stopping potential and current? Let me just explain a little bit. So, and also how the photocurrent depends on intensity. See, according to quantum theory, intensity means actually the number of photons passing per unit area, okay, per unit cross section, per unit time, maybe you can say. That means if you know the intensity is suppose intensity is I1 for this, and I have same area. So when number of photons per unit area is less, then this is I2. That means, you know, you have, see, according to quantum theory of photoelectric effect given by Einstein. So when a metal surface is actually bombarded by, or not bombarded, I can say, it is exposed to a light, so light actually will have tiny photons. Okay, so those photons, actually the light is having particle nature in this case. So each photon will knock out one electron, photoelectron. Okay, so each photon will go and hit an electron to knock out from the metal surface. So if you have more photons, if you have more intensity, then you have more photons. Then when you have more photons, then more electron will come out, so you will get more current. So intensity is greater means current is greater. That is very nice. So you look here, I1 is greater than I2. That means the current is greater, current is greater, current is greater. So this current is less here for I1, so this is not true. I can just then I can actually leave this option D. Now I have option C, option A, option B. These are all seems to be correct according to the explanation of the intensity and current relations. Okay. Now I have to see what is stopping potential. You know, we have cathode and we have anode, right? The stopping potential is actually that potential which is applied in the reverse direction between cathode and anode. Suppose here some negative potential is given and here some positive potential is given, then electrons come out from this cathode. They will actually be repelled by this negative potential of the anode. But still, since these electrons will have enough kinetic energy, then they will reach to the anode and there will be a photocurrent seen in the circuit. But suppose if I increase this negative potential here gradually, then electrons, see, electrons have kinetic energies of different ranges. Okay, not only a single range. Electrons will have kinetic energies which are coming out of the metal surface will have distribution of energies, not a single energy. So as you increase the stopping potential or the reverse potential, then the electrons which have enough kinetic energy to overcome this barrier or this opposing potential, they only will actually reach up to the anode and then flow through the circuit. So gradually, you know what will happen, the number of electrons reaching to anode will be decreasing. So look, if I increase the voltage in the reverse direction, gradually current is actually decreasing. But whether they will have same negative potential to make the current zero with same intensity, sorry, same frequency but different intensity. See, the kinetic energy the electrons will have, that depends on actually the excess energy. See, I have photon, incident photon energy h nu, I have threshold potential, sorry, threshold energy or threshold frequency nu 0, or the work function energy is h nu 0, then I have excess energy. So this energy will actually give the kinetic energy to the electron to reach up to the anode. Now, you know, if this incident photon has more frequency, suppose I have two lights, okay, so one has intensity I1 which is greater than intensity I2, but both of them have the same frequency. If both of them have the same frequency, then the photoelectrons ideally coming out of the metal surface will have the same kinetic energy. Okay, same kinetic energy for both the lights. Okay, so you know, then the stopping potential to make the current zero will be same for both the lights. Okay, both the lights, so both of them will have the same stopping potential, as it depends on frequency, now it does not depend on intensity. So stopping potential depends on frequency, incident frequency, but not the intensity. Okay, so you look this option, first option will be the correct answer. This is A, option A will be the correct answer for this question. Okay, now let us go to the next problem. So this problem is saying that consider the network shown here. You look this, consider here, sorry, this network, you know, there are two diodes and this is one resistor, and see the potential applied across this. Suppose this point is P, this point is Q. This is actually common point for all these three branches. You look, this branch has 15 ohm. This actually has 10 ohm resistance along with the resistance of the diode. And in this case also, in this last branch, there is 5 ohm resistance along with the resistance of the ideal diode. Okay. So in this case, the question is saying that equivalent resistance of the network. So what is the equivalent resistance of the network? So to find out equivalent resistance of the network, we need to know through which branch or how the current flows here. See, this point has got positive 6 volt and this has got a negative 8 volt. Okay, that means, you know, this diode will be actually forward biased. Okay, forward biased, and this will be actually reverse biased. See, this P terminal is given lower potential, and here it is negative potential is more, okay, than the positive potential. So this is actually, you know, this is forward bias. So this is forward biased. So it is forward biased. That means, you know, this for an ideal diode, when a diode is conducting, then resistance is taken to be 0. So you have now effectively this circuit. See, this is of 15 ohm, and you have another part. This is having 5 ohm, and for an ideal diode, the resistance will be 0. Okay, that's why I'm not keeping the diode here. So I have this equation now. Okay, so this is parallel combination, right? So I have equivalent resistance R is equal to multiplication. Oh, so I see this is 10. So this will be 150 divided by 25, which is 6 actually. 6 ohm. So option D will be the correct answer for this question. Okay, so I'll have few more questions over here. We'll discuss few more questions here. There is actually a very interesting problem. See, I'll write down instantaneous current in a circuit is instantaneous current in a circuit is shown or is given. Okay, is given as I of t is equal to 6 plus square root of 54 sine of 2 pi t plus pi by 3. This much. This is an ampere. So what is the question? Question is, what is RMS value of the current? What is the RMS value of the current? So the options are 2√6 ampere. Option B is 7 ampere. Option C is 3√7 ampere, and option D is 6√2 ampere. Okay, so here, this is very interesting problem. You have to find out what is RMS value. So you can see that there is a term like this. When you have only this part, this is the peak value. But in this case, I cannot say this is peak value, this is another peak value, etc. I cannot say. And also, this is actually having dimension of the current. So I can say this equation, say kind of this. I can say kind of this I1 plus I2 like this. Okay, so if I have to find out, see I2 is actually root over 54 square root of 54 sine 2 pi t plus pi by 3 ampere. Okay, this is I2, right? So I know, this case IRMS is square root of I1 square. So this is integration. So I have to take the square average. Okay, 1 over the full time cycle 0 to t I dt plus, that means I1 dt, I1 square, sorry, I1 square to t. This is 1 over t 0 to t, and this is I2 square dt. See, I2 is this to 1. Okay, look, then this will give you actually what we have itself. Okay, that means 6 square. Okay, and what about this? This much is okay, and the sine square, this thing will give you actually 2 divided by 2, this much. Okay, look then what we get here, 6 square plus 27. Okay, this is 36. 63 square root of 63, that means this is 3 into, sorry, 3√7. So this is actually RMS value, 3 root over 7 ampere. Okay, all right, so you can see these options. Option C will be the correct answer for this question. Okay, I have got another problem. Let us try to solve that also. Before that, let me write it. The equation of stationary, the equation of a stationary wave is given as, stationary wave is given as y is equal to 2a sine 2 pi by lambda into nt cos of 2 pi by lambda into x. Then which of the following is not correct? Which of the sorry, which of the following not correct? Options are dimension of x is L, dimension of x is L, dimension of n is L to the power minus 1. Dimension of n by lambda is t. Dimension of option D is dimension of nt is L. Okay, see here 2 pi by lambda, this is actually k vector. 2 pi by lambda means k propagation vector. K, see what we know, 2 pi by lambda is k nt. First of all, the whole thing will be dimensionless if I take the whole thing. Okay, let me take this 2 pi by lambda into nt. 2 pi by lambda into nt. The whole thing will be dimensionless. So how do I get dimensionless quantity over here? So this is of no dimension, like 0 dimension. This is having L. So L inverse. So what it has to be? So this is actually to have to have see this has to be actually L to the power minus 1 into T, so that you get, I'm sorry, we have to get dimensionless quantity. So T, anywhere T is T, so N has to be this. Okay, so N has to be this L to the power minus 1. So L to the power minus 1. But what is given here? N is given as L to the power minus 1, that is fine. Now if I say N by lambda, one option is given N by lambda, right? N by lambda is T. Let us see, N means L to the power minus 1, N by lambda. N is L to the power minus 1 and by lambda is this. So I have got time inverse actually. But here it is given only time. That is why option C would be incorrect. N by T is So it should be t to the power minus 1, not t. Okay, so option C will be the incorrect option here. Okay, so I'll stop it here just with a comment over here. I'll cross check this question once again. Up to this, it is all right. Like calculation of equivalent resistance 3R by 4, 3 by 4 R. This is very correct. Okay, and we have to find out what is current. So this will actually cross check. Okay, this I'll cross check and tell in the next class, maybe tomorrow, what is the current. This I have to find out. Okay, so all right, thank you for your patience. Bye for today.